So now I have a corollary to prove. Let x, y, and z be my norm spaces, and the formula ST defines a continuous mapping where S itself is a continuous mapping, T itself is a continuous mapping, and ST together is also a continuous mapping. So think of this in this way. So my operator S takes me from Y to Z, and my operator T takes me from X space X to space Y. So if I have a vector in my space X, when I apply operator T to it, in Y space what I get is this quantity Tx. And now when I am in, so Tx is an element in Y space. If I take an element or a vector in Y space and apply my operator S to it, I get a vector in my Z space, which is represented as STX. So if we go and look back to our definition of our norms operators, we come to the point that this STX can be split up into two different paths, norm of S and norm of Tx. So the reason why we were able to do this is again because of the linearity. Another thing that you can see from this is that I can consider my Tx. So another thing that you can see is I can separate this into two parts is because I consider my Tx to be just an element or just a vector in space Y. So that's why I can separate it into two pieces. And again, I can do the same operation here and write it as norm of S, norm of T, norm of X. And I can see very well that the norm of ST as an operator. So together, ST is an operator which takes elements in my space X to space C. So I again write the definition of the norm of the operator as the sup norm, norm of x equals to 1, STX, and of course it's less than norm of S, norm of T. Now let us take sequences in our space Y to Z. So this space is the space of all bounded functions from vector space Y to vector space C. And similarly, this is the space of all bounded functions from X to Y. So if I have my sequence Sn tending to S and Tn tending to T, as n goes to infinity, I observe that if you look at this equation carefully, so if you look at this equation carefully, you see that here all that I have done is I took my ST, and this Sn and Tn are sequences, and I just added and subtracted minus Stn and plus Stn. And then again, based upon triangle inequality, I can take S out here, and here it would be T minus Tn, and I can write it separately at like this. And similarly, I can take Tn out and I can write it separately at this. And my assumption was that as n tending to infinity, Sn goes to S and T goes to Tn. So these corresponding quantities would be 0. So my final result of this thing is 0 as n tending to infinity.